Combinations and permutations. There are 8 boys and 7 girls running for 4 identical council positions in student government. How many ways can the 4 positions be filled? I have 15 students going for it, guys, but I need to get 4 out of the 15, so how many combinations? Because they're identical, okay? So that's a combination. So it's 15, choose 4, and it's a combination. You can plug it into your calculator, and there's the formula. You get 1,365. So here's the next part about it, right? So what's the probability that every single person who gets on this council are girls? Here's the thing. I know this is how many ways I can get it with boys and girls. So how many ways can I just have girls needs to be on top because they're talking probability. I want to show my work, right? Combination, check it. 7, 4. Cha-ching. 7 girls. How many ways can I choose those 7 girls? I want 4 of them. I get 35. So 35 over 1,365. I get 0.0256. Yes. Very surprised at it being all girls because you have a very low probability of that occurring. So Abby, Beth, Caitlin, and Darcy won the 4 positions for student government. Now they need to decide who among them will serve as vice president and president. So you have 4 options. So how many ways can someone serve as president? 4 ways. How many ways can someone serve as vice president? 3 ways. 4 times 3 is what? 12 ways. Next one. So you're going to the smoothie place. You get 15 ingredients. 5 of them are vegetables. 10 of them are fruit. First question, how many possible 3-ingredient smoothies would contain only 3 fruit? So it's a combination. 10 for fruit, 3 that, 120 ways. How many possible can you get out of total? So that's going to be 15, choose 3, which is 455 ways. So what's the probability of randomly just picking something that you're going to get only fruit? 120 over 455, which is 0.26537. Next question, in an ice cream shop, you have these 5 flavors: chocolate, vanilla, birthday cake, cheesecake, and mocha. Alex wants to build an ice cream cone. How many ways can he order? You guys, when it's order, you think permutation or fundamental counting theorem. So I can go 5 times 4 times 3 times 2 times 1, which is 120 different ways to order the scoops. So he realizes he's not that hungry. He can't eat 5, he only wants to eat 3. So how many combinations of 3 different flavors can he do? Combination. So you need to be using C. 5, choose 3. Right? This is a permutation, which would be 5, choose 5, which would give you 120. 5, choose 3. So then I only get 10 ways to combine 3 scoops of ice cream out of my 5 options. If Alex chooses his 3 unique flavors at random, what's the probability that he chooses 1 scoop each of chocolate, vanilla, and mocha in any order? How many ways can you only choose 3? 10. That's just one specific order. 1 out of 10, which is 0.1. So 10% chance he chooses chocolate, vanilla, and mocha. So on this one, this is a legit question, guys. So car shows get a ton of entries, and you'll have multiple stuff that's best of show. The car show needs to award 5 best of shows. You have 47 entries. How many combinations of best of show are there in the car show? 47. Choose 5. I'm looking for combinations. The word question says combinations. So when you do that, you get that. 1,533,939 ways to do that. Pretty impressive. How many ways can the best of show be ordered? Right? 5 times 4 times 3 times 2 times 1, which is 120, or it's a permutation. 5, choose 5. Right? And what's the probability the best of show awards given were filled by cars built for the 1970s? So 47, choose 5 is on the bottom. There's only 22 cars built in the 70s. If all 5 of them were for that, that's how many options I have. So then I divide out of it. So that all the cars are built before that, 70, get best of show. Very, 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 very low probability. Okay. Miss Bell's class at Running Bird Elementary lines up for lunch. The class has 12 kids, 5 girls and 7 boys. How many different ways can the students line up if a boy has to be at the first of the line and at the end of the line? So how many boys do I have? 7. So this is boy 1 at the first of the line, and then this is going to be boy 2 at the last of the line. So 7 ways I can pick a boy here, only 6 ways I can pick a boy there. But here's the thing. I have 2 of them gone. How many students do I have left? So this is the rest of my students. 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 for them to line up. When I multiply that out, you guys, really huge number. Okay, so 2 students are selected to eat lunch with Santa Claus. How many combinations are there for selecting 2 students? I got 12, choose 2, because it says combination, so 66 ways for me to choose 2 kids to send down to eat with Santa Claus. What's the probability that both the kids you send down are girls? Because girls rock. So, combination 5, choose 2 over 66, because that's how many I have total, so it would be 10 out of 66, 0.15. I'd be a little bit surprised. It's still pretty high, but not like massively high. So, this one, going through it, guys. If Bert and Emily wants to sit together in a way, how many ways can I do it? So, Bert and Emily, XXX, X, Bert and Emily. So, I got 1, 2, 3, 4. There's 4 ways for Bert and Emily to set. Okay? I can set them either as Bert and Emily or Emily and Bert. So if I do it that way, I got 1, 2, 3, 4, 5, 6, 7, 8. So 4 times 2 is 8. So then I need to take and count the rest of the group. So I can have 3 ways, 3, 2, so I can do 3 there. I can do 2 there, and I can do 1, right? So 3 times 2 times 1, which is 6. So 6 ways. And then I got to take that into account, 8 times 6, so I get 48 ways.